Hello Year 11, welcome to Revision Week 2. This week we are looking at the FDE cycle and what is meant by the von Neumann architecture, both continuing on looking at the CPU. You should have your revision sheet 1 from your revision pack, please. We are finishing off this sheet today, the one we started last session. Revision sheet 1. Can you get that now, please? Okay, last session we looked very quickly at what a computer system is, the basics, made up of hardware and software, takes inputs, processes, creates outputs. And we looked at what different types of computer systems are, including embedded systems. Embedded systems have a limited number of functions, require less power, and can be used cheaper, less powerful processors. And we also looked at the main parts of the CPU, the control unit, controls the flow of data, the arithmetic unit carries out logic operations, and the cache. Quick access memory stores regularly used data. We are now finishing off by looking at the registers today. Registers are super quick memory that store tiny bits of data, and there are 4 that you need to know about for this exam. And remember, the purpose of the CPU is to process data and instructions by carrying out the fetch, decode, execute cycle of instructions. And that is what we are looking at today. So remember, in the CPU, we said there are 4 registers. Registers are super quick memory, the fastest memory, and they are used to store tiny bits of data used by the CPU. Literally a single number or a single address. Okay, a number, address, or an instruction. And there are 4 registers that you need to know. There is the PC, or the program counter. This holds the address, the memory address of the next instruction that it's going to complete. PC, program counter, next instruction that it's going to complete. We've got the accumulator, the ACC. It stores the results of any calculations that has been carried out by the ALU. So the ALU does the calculations and the accumulator stores the results, so it remembers it. We've also got the MAR, the memory address register, holds the memory address about to be used, so the one it's about to get and do. And then the memory data register, the actual data instruction being used at the moment. It's like a buffer that holds data that's being transferred to and from memory. Okay, holds the actual data instruction being used at the moment. Okay, so you need to know these registers. At the very least, I want you to try and remember 2. If you can, make a note on all 4. But what is a register? And at the minimum, write down and remember 2, please. Do this now. Pause the video, see what you can remember, and then check your answers in a moment. Okay, time to check answers. What is a register? Super quick memory used to store tiny bits of data being used by the CPU. And there's your 4 registers. Program counter holds the memory address, current memory address, the one that's about to be used. Accumulator is used to store the results of calculations. Memory address register used to hold any memory address about to be used. And memory data register holds the actual data instruction that has been fetched from memory or is being used at the moment. Okay, so now we know about the registers and what they are used for. How are they used in the whole process? What you have in front of you is the basic design for a CPU, the basic idea. And this architecture, this design is called the von Neumann architecture. It's the basic structure of how CPUs kind of work today. In this design, where are all the programs and instructions stored? Well, while the computer's running, they are loaded and stored in memory down here. We have main memory, your RAM, where they are stored. So they are loaded and stored in main memory. The CPU then has to fetch those instructions from main memory to get them and bring them into the CPU to process them. So what is the von Neumann architecture? It's basically this. The von Neumann architecture is a system where the CPU runs programs stored in memory. Your programs are loaded and stored in memory, and the CPU runs those programs. Programs consist of instructions and data that are stored in memory addresses. So that each instruction is saved in a memory address, and the CPU fetches these instructions, decodes them, and executes them. FDE. And that is what the von Neumann architecture is, just in case you get asked a question about it in the exam. Von Neumann architecture. Make a note, please, now. Key sentence from the previous slide will help you to remember or get points in the exam if needed. Okay, checking your answers on the next part of the video. A system where the CPU runs programs stored in memory. Programs consist of instructions and data which are stored in memory addresses in your RAM where they are fetched from. Check your answers, please. Improve, add to, and let's move on. Okay, so this is the hard bit in a way to try and remember for the exam, and they often ask things about the FDE cycle: fetch, decode, execute. Remember, the CPU processes data instructions, and it does this by doing the FDE cycle. It fetches instructions from your RAM, it decodes them so it understands them, and then it executes them, it carries them out. But what actually happens? What do you need to know for the exam? Well, you need to know that instructions are fetched from main memory, from your RAM. So the CPU goes to RAM and fetches the instructions. Straight away, there's a point. It decodes the instructions in the control unit. Part of the CPU decodes the instructions. And it executes the instruction, carries out the instruction, and then it goes back and starts again. The whole cycle starts again. Fetch, decode, execute. Very simple version. Okay, one time around, one cycle is called 1 hertz. 1 hertz. 1 million times around per second is called 1 megahertz, and 1 billion is 1 gigahertz. That is also important to know. So, just so we have a bit more understanding, let's have a little demonstration, more complex version. Okay, fetch. Well, we've got a number in our program counter here, 0, 1. That is our first instruction. The program counter points to the address of the first instruction. The instruction is going to get from RAM. The program counter is copied to the MAR. The address in the program counter is copied to the MAR. So that would give you points in the exam as well, if you can remember that. Whatever is the instruction in the MAR is then fetched from the RAM. It goes to RAM and gets that instruction from wherever it is. That instruction is then copied into RAM, into the CPU, into the MDR. And that is the fetch stage. The program counter is then incremented, increased by 1, ready for the next time around. Fetch stage complete. Decode. Well, that's simple. We've got an instruction here, but we don't know what it means. So the instruction in the MDR then needs to be decoded so we understand it. The control unit takes the instruction and it decodes it so we understand. In this case, it was add 6. So we're going to add the number 6. The control unit may then load new variables or new values into ready for the next stage. In this case, the value 6 is copied down to use, and then execute, it does it. So it's going to carry out the operation. In this case, add 6 to whatever was in the accumulator. So we've got 6 plus 8. It adds it together, gives us 14. And that value is then stored into the accumulator. Because remember, the accumulator stores any values calculated by the ALU. And the cycle is now finished. It would then move on to the next instruction, which is 0, 2 from memory. 1 cycle done, 1 hertz done. The cycle then repeats with the next instruction. Okay, so what do you need to know for the exam? Fetch. Instruction is fetched from main memory and copied into MDR. If you can remember that, those are 2 points straight away. Decode. Instruction is decoded by the control unit. and a new value may be loaded into the MDR or MAR, ready for the next stage. There are 2 points there as well. Execute, the instruction is carried out, and then the cycle repeats. Those are 2 points for each stage. If you can remember those, that will get you points in the exam if you're asked about the fetch, decode, execute cycle. Okay, complete the boxes. I wanted at least 2 points, 2 things that happens at each stage. Fetch, decode, execute. If you want to do more detail, you're welcome to, but try to remember at least 2 things. Pause the video now, try to write it down, and then check your answers in a moment. Okay, time to check. Checking your answers on the screen, at least 2 points. Instruction is fetched from main memory, copied into MDR. Instruction is decoded by the control unit. New value may be loaded into MDR MAR. Decoded instruction is carried out, and then the cycle is repeated. Make sure this is clear in your head. Make sure you have notes on your sheet. Pause if necessary. Quiz time. Now you have your notes. Use them to help you. You're going to learn CUMDine, computer science, revision topic, and then complete revision quiz 2. Remember to check each answer, and if correct, move on. Otherwise, correct your answer by trying the question again. 100% correct is your target, Year 11. Good luck. Come and see me if you need support.